சரியா?
அடி விளையாட தெரியுமா ஆனால் தூங்குவேன். நார்மலாக தான் விளையாடுவேன்.
Very good afternoon to everyone. Let's start the seminar on optimization of machine learning algorithm for better healthcare service. We started by guest Dr. V. Chandran sir. Welcome you sir. Sir, your voice can't audible sir.
Hello.
Sir,
Now it's okay, right?
yes sir.
Yeah.
Yes, sir. Now it is audible, sir.
Thank you. Thank you. Okay. So you know that the topic is just give me 1 second. Solving healthcare problem using a machine learning techniques. Okay. So for this particular session, I have taken the breast cancer diagnosis data set. Okay. So which is most widely available in Kaggle or UCA machine learning repository. Okay. So go and gather this particular data set. Okay. So as per this particular topic is with respect to machine learning, I have included most of the machine learning algorithms or famous machine learning algorithms to solve this particular problem statement. Okay. So first, with respect to description, why I'm taking the breast cancer is breast cancer one of the most common cancer among the women in the world. Okay, so it accounts for more than 25% of the cancer causes and affected over 2.1 million people in 2015. But now that has been increased very exponentially. Okay, so it starts when the cell in the breast beginning to grow out of control. Okay, so it is like there is some unwanted cells growth in the breast of the women's. Okay, so these cells usually form a tumors that can be seen via x-rays or felt as a lumps in the breast area. Okay, so The key challenge against this particular detection is how to classify the tumors into magnitude, that is a cancer or benign. Okay, so it is non-cancerous cells. Okay, so so it is like a complete analysis of classifying the tumors using the machine learning with SVM and some different machine learning algorithms. Not only SVM, we will discuss about logistic regression, gradient boosting, like that. Okay. So this is the description. Okay, and this dataset has been taken from Kaggle. Okay, I'm acknowledging the Kaggle for the same. So the objective would be like understanding the data set and cleanup. Okay, so most of the data scientist role, whatever we are looking in the industry, their 80% of work would be like cleaning the data. Okay, so once we have the cleaning and more useful data, then building the model upon it's very easy. Okay, so first we have to go. We need to understand the data set and clean up, and then we are going to build the classification model to predict whether the cancer type is a malignant or benign. Okay, and so we are going to fine tune the hyperparameters and compare the evaluation metrics of various classification algorithms. Okay, so these are the primary objective for our this particular case study. Okay, so what are the steps it has involved? Are first start with the data exploration, and then we are going to perform exploratory data analysis, data pre-processing, data manipulation, feature selection slash extraction, predictive modeling, project outcome, and conclusions. Okay, so these are these 7 steps we are going to perform with respect to this problem statement. Okay, so first step is a data exploration. I'm going to import different dataset libraries or data science libraries. So one is import OS. Okay, so whenever we are going to access any path, okay, like if you are using the local drive, okay, so like C drive, E drive, D drive, so we have to use the OS path because in Kaggle why we are using is, so we are going to call this is the dataset path. Okay, we are going to use this particular path. That's why we are importing the import OS library. And next is import math. If you want to do some mathematical computation like or mathematical things like calculating the pi, something like that. Okay. So next import SciPy. SciPy is nothing but a scientific Python. Okay. If you want to do some scientific computations, okay, then we have to use SciPy and NumPy. So which is the most prominently used library, which is also called a numerical Python. Okay, so it has been useful for do all the numerical computation in the data science. And then pandas, the pandas has been used for data formatting, and Seaborn. Here we are using the Seaborn library to for visualization purpose. Okay, and then we are having a TQDM, so which is useful for all the in order to understand the time computation of each and every algorithm, and sklearn, which is also called scikit-learn. So from scikit-learn I'm importing the tree, and from scipy.stats. Okay, so machine learning is not only data science, not only with the machine learning or Python. Okay, we have to understand the stats also. Okay, so statistics plays a vital role in most of the uh, preliminary steps in data science pipelines. Okay, so I'm importing from scipy.stats, import a random initialization, and from scipy.stats import log uniform. Okay, and then from ipython.display I'm importing the display. Okay, so these are the some basic libraries. And then from sklearn dot decomposition. Okay, so decomposition nothing but it is a dimensional reduction algorithm. Okay, here I'm using the PCA. Okay, and then from IMB learn. Okay, so there's an imbalanced data set. Okay, so from sklearn we are importing this for, so that's why it is from IMB learn dot oversampling imports mode. Okay, so for addressing the data imbalancing, so we are having a different oversampling technique. One of the oversampling technique is called SMOD. Okay, so SMOD stands for synthetic minority oversampling technique. Okay, And then feature selection, which is also another technique that has been performed the data exploration, which is called recursive feature elimination. Okay, so we will discuss in the upcoming cells. And then from the sklearn dot pre-processing import or not encoder. Data encoding is another important concept in machine learning. Okay, so can anyone say what do you mean by encoding? What do you mean by encoding? from import, I am having the breast cancer dataset. In that, I am having the breast cancer.csv. Okay, I am going to drop the ID because I don't want the patient ID. Okay, I'm going to drop the ID, and I'm target will be a diagnosis. Okay, if you open this data set, you can see we are having the ID, right? So ID is a primary key. It will not change. It will not give any useful information about the data. So that's why we are removing the ID. Okay, and then our target variable is diagnosis because diagnosis will have M, and M stands for magnitude, and okay. So then we have the labels a lot of benign and malignant. Okay, so that's why B stands for benign and M stands for malignant. Okay, so then we have to extract the features. Okay, so I for I in df.column.values if I not in target. Okay, so we have to remove this target cell. Okay, which is as a diagnosis. Okay, and we will have the deep copy of all this data set. Okay. Okay, so this is how the datasets will be like. Okay, the inferences dataset consists of 31 features, and totally we are having around 569 samples. Okay, and then the next step is checking the data types of all the columns. Okay, so why we need to check the data types of all the columns is that you know that machine learning algorithm will understand only a numerical values. Okay, if you are having any categorical values in the data set, okay, we have to remove that. But if you check your data set, only we are having the categorical values, categorical in diagnosis only. Okay, but none other than that having the categorical values, all of numerical value only. Okay, so anyway, we are going to check the data set info. Okay, so if we check that we have diagnosis, which is called object. If it is a data type is object, then it is defined as a categorical variable. Okay, but other than that, everything is a floating point 64. Okay, so if it is if you are having any of the categorical variable inside your data set, then we have to do a encoding technique. Okay, and then going to check what are the unique values with respect to each and every features. Okay, so you know the total number of samples is 569. Okay, so we are having only two unique values for diagnosis, which is called the cancerous and non-cancerous. That's benign and non-malignant. And then if you take a smoothness worst, we are having around 411 unique values. Symmetry mean we are having around 432 unique values. Okay. So then after that, checking the number of unique rows in each features. Okay. So the dataset has 30 numerical and 0 categorical features. Okay, you know that total number of features is 31. After removing this target variable, it is 30, right? So that's what we are calculating here. So the dataset has 30 numerical and 0 categorical features. Okay, so then I'm going to use df.describe command, which is very important. Okay, so it will give a clear picture of your dataset. Okay, so what is the number of counts? Okay, so that is the total number of features. What is the mean value? Okay, so mean is the average value, and what is the standard deviation, and what is the minimum value in each and every column, and what is the 25% of that value, 50% of that value, 75% of that value, and maximum value. Okay, so this is called a stats. Okay, so it will help us to determine all the different statistical parameters and also for useful for hypothesis testing. Okay. So the dataset seems the stat seems to be fine. Let us gain more understanding by visualizing the dataset. Okay. So now the first part is that data exploration that has been completed, and the second part is exploratory data analysis. Okay, it is a very important step in most of the data science life cycle. Okay, so let first analyze a distribution of the target variable. Okay, so I'm just declaring the dictionary map, an empty dictionary. Okay, I'm going to map the target variables, that is I'm going to calculate the magnitude and benign. Okay, so if you check for the target variable, okay, so 37.3 percentage of data set out of 100 is related to magnitude, and 62.7 percentage is benign. Okay, so what you are getting out of this particular data distribution? Can anyone say what is the inference we are getting out of this? What is the inference we are getting out of this?
Benign is greater than malignant.
Okay. Any other thing? Okay, so from the inference, what we are getting is that the data is not balanced. Okay, the data set is imbalanced in nature. Okay, so for this, what we are going to do is we will do some stats technique to address this issue. Okay, we will discuss later. So the inference is the target variable seems to be slightly imbalanced, hence we shall try to perform a data augmentation technique. Okay, so visualizing the categorical features for each and every row, we will have so for categorical, we don't have any features because you know that we don't have any categorical features in the data set. Okay. So let me go for other features. Okay, other than categorical features. Okay. So n equal to 6, that is for each and every row, we will have 6 graph. For I for I in features, if I not in CF. CF is nothing but a categorical features. Okay. We don't have any categorical features, then it is not an issue. Okay. So plot dot figure equal to size of 513, so 15 comma 3 into math of ceiling value, length of the features divided by n. Okay, you know why we are using the math. So this math library useful for doing the ceiling operations. For C in range of length of nf, plot dot subplot math dot ceiling, length of the features divided by n comma c plus 1. Okay, so SNS dot dist plot equal to, so we are calling this list. Okay, so let me run this particular cell. Okay, so you can see, so this is the density radius mean. Okay, so this will help us to understand how the data has been distributed. Okay, so why it is needed is that if you want to make your machine learning model should be data science or any machine learning model to be work well, then we have to make the data that has to be distributed normally. Okay, like this is a normal distribution, like there's a bell shaped curve. Okay, every data distribution should be normally distributed. So then only we can able to get a desired and good that is a better model. Okay, so keep it in mind. That is very important. Okay, so after seeing that. So like this one is not that much normally distributed, but okay, it's somewhat normally distributed, and this is exactly normally distributed, and this is also normally distributed. Okay, and this is not normally distributed. Okay, so most of the cases seen, the data set is normally distributed. Okay, this is a disk plot used to identify the outliers. Okay, you can see, so the data point that has been fall above this or outliers. Okay. So the inference what we are getting is the data set somewhat normally distributed, and there are many outliers present in the data set, and we need to fix these outliers before building the model. Okay, so G equal to SNS dot pair plot df1 comma u equal to target psi. So this will give understanding the relationship between all the features. Okay, so pair plot. Yes, it will take some time to run. So okay, so this is not needed. Okay, so I've just stopped, cancel this running. So we will check after our final thing also. Okay, so the next step would be like data pre-processing. Okay, so data pre-processing, like we are going to find if there is any duplicate rows in the data set. Okay, so if there is any duplicate row, we have to remove that. Okay, so row comma column. Okay, so if we are having any duplicates in the rows and columns, we are going to remove that. In front, what we are getting, the data set doesn't have any duplicates. Okay, and then check for empty elements. Okay, the empty elements will be mentioned by NaN value. There is a none value. Okay, we need to check whether we are having any null values in the data set. So after checking that, we are seeing that there is no null values present in the data set. Okay, so next is converting all the categorical columns to the numerical column. Okay, so we don't have any categorical values other than target variable, right? So that's why we are only applying for a target variable. Okay, so for I comma e dot enumerate df1 target dot unique value, and we are going to perform a one not encoding, one not binary encoding value. Okay, so if you perform this, the m will be converted to 0 and b will be converted to 1. Okay, in the target variable. So if you want to check a data set, to df3 dot header. You can see now the diagnosis has been changed to, in diagnosis, m has been changed to 0. Okay. And then removing the outliers. Okay, so what do you mean by outlier? Anyone? What do you mean by outlier? Okay.
Large distance between all the data.
Okay.
Sir.
So thing is that the outlier is, so we have some data points. Okay, if any one of these values that has been fall outside of that particular range, then we may define that as a outlier. Okay, so how can we remove that outlier? Okay, so we are having the IQR plot technique to remove the outliers. Okay, so that's why we are using this. So whatever the range that has been fall from 25% to 75%, so we are going to remove that. Okay, that is from quartile 3, from in between the quartile 1 and quartile 3, we will have the data set. Other than that, we are going to remove the value. Okay, once you can see after removal of outliers, the data set has 569 before removal. After removal of outliers, the data set has now 502 samples. So more than 67 samples has been removed. Okay, so then data set imbalancing. Okay, so we see the data set that has been imbalanced in nature. Okay, so if you want to overcome this issue, we are going to use a technique called SMOT, that is a synthetic magnetic oversampling technique. Okay, this SMOT analysis will try to balance both the classes. Okay, so the name is synthetic magnetic oversampling technique. It means it will oversampling the minority classes to match with the majority classes. Okay, so you can see the original class distribution is 337 for class 1 and 165 for class 0. But after doing this SMOT analysis, now we are having both the classes have equal distribution. Okay, and then final data set size for after performing the pre-processing. So this is the retained data set and this is augmented data set, and this has been dropped. 7.3% has been dropped. The inference is the final data set after cleanup as 674 samples and 31 columns. Okay, and then data manipulation. Okay, so here we are going to convert the data set into training set and the testing set. Okay, so we are originally the data set has been 674, 30. The training set have 539 data points, 30, and the testing set having 135 data points, 30. Okay, 30 is the number of features. Okay, so here I'm going to use the feature scaling. I already said that why we are going for feature scaling. Okay, so we are going for feature scaling in order to make the computation very faster and also remove the model confusing during the training time. Now that has been normalized. You can see before we are having around 38 like that, but now the data set has been normalized. Okay. So next is a feature selection. It's a very important stage. Okay. So I'm using the heat map, or it is also called the correlation map, to understand the correlation between the data points. The inference what we will get is the correlation plot between the variables convey a lot of information about the relationship between them. Okay, there seems to be a strong multicollinearity in the data set. Okay, so if you want to remove the multicollinearity, we are going to calculate the VAF value. Okay, the variance inflation method. Otherwise, we will have the automatic method called recursive feature elimination, or we will have the decomposition method called principal component analysis. So these three are the methods that has been used to remove the multicollinearity. So first we will understand the VAF value. Okay, I will share this code. You can just go through that. It is very basic Python only. But if you have understand the concept, then it is very easy to go through code. Okay, you can see. So this is for logistic regression. This orange one is for random forest, XG for XGBoost classifier. Okay, then we are having the RFE thing. So this is how the scores has been changing with respect to different features. Okay, so if it is, you can see initially we'll have very high accuracy, but whenever the number of features has been increased, then you can see there is a sudden drop in the accuracy. So here also same thing happening. Initially we are having very good accuracy for all the model, but after this point, that is now after the 25 edges, it is getting degraded. Let me check for PC also. We can see for initially 0, we have some good response, but after that, that has been constant. Okay, the variance has been constant. Okay, so we shall avoid performing the dimensional reduction for the current problem. Okay, we can use the PCA technique to address this issue. Okay, so PCA is a very one of the good technique to remove these correlated features. Okay. So then we have to finalize the shortlisted features. Okay, I'm using the recursive feature elimination technique to finalize. So you can see, so initially we are having the 30 features. Now we are having only 16 features, so 13 features. And then is a model predicting. Okay, so I'm going to use a table, so which is used to store the results of the various model. Okay, I'm going to use logistic regression, decision tree, random forest, naive Bayes, support vector machine, k nearest neighbor, gradient boosting, and extreme gradient boosting. Okay, so I'm going to calculate the accuracy score, prediction score, recall F1 score, and AUC ROC curve for all the models. Okay, so all this has been calculated with the help of a confusion matrix. Okay, so now the first we are going to build the model. So LR underscore model equal to logistic regression. This is how we need to call the logistic regression algorithm. Okay, so if you want to make this use of this algorithm, we have to pass some parameters. Okay, I'm going to use, these are the different parameters we are having. Okay, so I'm going to use the solver like a Newton CG, LBG, FBGS, lib linear, and I'm going to use the regularization technique to reduce the problem of overfitting. Okay, I am using a I'm using the L2 regularization here. If you want to use some other regularization also, you can use this. So this is different regularization technique we are having. Okay, and then I'm using the log uniform. Okay, so the value parameter C will be taken as a log uniform. Okay, so I'm using a CV, that's cross validation. Okay, I'm going to use a number of bits as 10. Okay, and then I'm going to use the randomized search CV for hyperparameter tuning. Okay, so let me run this particular cell. Okay, you can see the overall accuracy is 36.3 and the F1 score is 36.3. Okay, so this is how the confusion matrix. So 67, 1, 4, 63. Okay, so from this confusion matrix, they are calculating the precision recall F1 score. Okay, this is AUC ROC curve. So this ROC curve will determine. So if it is greater than 0.5, this is 0.5 line. If it is greater than 0.5 line, then the model is said to be that has been correctly classifying the data points. If it is below 0.5, it shows that the data set is not correctly classified. Okay. So this is interpreting the coefficients, that is y equal to wx plus b, right? So you can see it will give the which coefficients will play the vital role. Okay, it will give the positive correlation, and concavity mean will give a negative correlation like that. Okay, so next is the decision tree classifier. Here the parameter is maximum depth, maximum features, minimum sample leaf, and the criteria we are going to use Gini and entropy. Okay, so this is a warning we are getting, and don't worry, it will be sorted out. Okay, so the decision tree classifier is having a 91.9% accuracy and 91.8% FN score, and this is the corresponding confusion matrix. Okay, and this is ROC curve. Okay, this is ROC for class 0 and ROC for class 1. And this is overall decision tree. This is how the decision tree has been derived for this particular data set. And then is a random forest classifier. Here we will have some different random forests, different number of decision trees like 10, 20, 50, 100, none. And the maximum features we will use are 2 features, or we will take the square root of the features. and the minimum leaf sample is either 1, 2, 4, and minimum sample split is 2, 5, 10, and the number of estimators, the number of decision trees would be like 50 and 100. Okay. Other than that, that is all the things are common. Only we have to change this corresponding algorithm name. Okay, so for random forest algorithm, we are getting around 95.6% accuracy and effort score. So someone say why we are getting both accuracy and effort score? Because the number of samples is very low. Okay, so that's why we are getting the equal effort score and accuracy. Okay, and this is the interpreting the output of the random forest. Okay, and then it's a naive-based classifier. For naive-based classifier, we are getting around 92.6% accuracy and 92.616% of F1 score. And then for support vector mission, this is a support vector mission parameter, that is C is a constant value, and gamma and kernel we are using the radian basis function. In some time we will use a polynomial kernel, linear kernel also. And you can see the accuracy is 97.8% for this support vector mission. And then is k nearest neighbor. We will have we will calculate the k nearest neighbor using this equation for I in range of 1, 30, 5. We will decide the number of neighbors. Okay, so you can see the accuracy is 97% for k nearest neighbor. And then final algorithm is gradient boosting algorithm. Okay, the gradient boosting algorithm usually take so much of time to do the computation because it is using the gradient technique. Okay, so you can see the accuracy is 97.8% for gradient boosting algorithm, and this is the extreme gradient XGBoost. XGBoost we are getting 96.3% accuracy and F1 percent 96.3%. And we are going to put all the confusion matrix for all these 8 algorithms, and we can also compare all the model scores. Okay, so for logistic regression we are having 96.3%. Okay, and there is accuracy, precision, recall, F1 score, and AUC ROC curve. Okay, so for the current problem statement, it is more important to focus on recall score. Okay, why? Because as most of the medical data set, we will focus on recall other than precision, F1 score, and accuracy. Okay, so now we can note from the above heat map that the support vector machines and for extreme gradient boosting and linear regression model performed better on the current data set. Okay, we are only focusing on the recall part. Okay, so we will have support vector machine and then KNN gradient boosting, extreme gradient boosting, and linear regression will logistic regression will play the vital as a better model for this particular data sets. Okay, so this is how we need to analyze all the algorithms with respect to data set, and also with respect to the application. Okay, so I have completed my hands-on session. If you have any queries, okay, you can unmute yourself and you can ask. Any questions? Okay, so if there is, yeah, there is one question. Yes, the outlier will be identified by using either box plot or you can use QQ plot to understand the whether we are having the outliers or not. Okay. Any other questions? Okay, so if there is any doubts, we can wind up the session. Yeah, so thank you everyone for giving the. If any method to treat outlays, yeah, if you want to treat outlays, we have to calculate that IQR plot. After performing the IQR plot, you can use vincerization technique to remove, or you can use capping technique to remove to treat the outliers. Okay. Okay, so thank you everyone. Sir, Arpasamy sir.
Thank you, sir.
Yeah, thank you very much.
Please wait, ma'am will join with us in 5 minutes.
Dear participants, please wait for 5 minutes. Ma'am will continue.
Next session starts in 5 minutes. Dear participant, kindly hold on. Feedback form post in 3:45.
Yes, good afternoon. We can start the event. Just 5 minutes. Give me 5 minutes. Yes, you can give the introduction. I will join.
Good afternoon, ma'am. I'm sure that you all will enrich with knowledge after completion of these events. Next, our guest speaker, Dr. D. Kartika Renu ma'am, will present the screen.
So just give 5 minutes. I will start the session.
Okay, ma'am.
Yes. Yes, you can hear me, right? Can we start the session?
Yes, ma'am.
Yes. So let me present my screen. Just hold. You please verify whether my screen is getting presented.
Yes, ma'am. Civil.
It's coming, right?
Yes, ma'am.
Okay. Yes, the screen is visible, right, everybody? Okay. I hope you would have enjoyed last few sessions by Chandran sir. So now we'll start with this session, which is a role of machine learning in precision medicine. Okay. Yes, in the morning session, we have discussed on how the machine learning models are useful, or how it is, why it is important for or how the latest development of computer science, how it is like machine learning or blockchain or artificial intelligence, how they are applied over healthcare service, okay, to provide better service. Okay, so in today's session, on the in afternoon session of mine, I'll brief you on how the machine learning algorithms or machine learning models are applied over the healthcare records, okay, in order to provide security. Okay, so when we say about healthcare data, okay, it is all the patient data, the public data, people's data. So the most important concern is going to be on the data confidentiality and the privacy. So with that, for that, what is the measures, or what does the machine learning algorithm do, or what does the latest technology do for preserving them? So that is what we will be discussing in today's session. So the title is on privacy preserving blockchain based electronic health records using ZK snarks. So introduction, it's like first is healthcare. Healthcare is concerned primarily with three important things today. We all know, like unlocking the value of data for insights that will drive precision medicine and population health. Second one is for improving efficiency by enabling seamless digital experience for patient and caregivers. Third one is for ensuring security and privacy in transmitting and storing the personal healthcare information. So for the third issue only, we are addressing the third issue. So we have addressed the first issues, the first two issue by in the morning session by applying the machine learning models over the patient on healthcare services, okay, and handling the multimedia data or big data like video, voice, and or images and all. And now we are concerned on security and privacy in transmitting and storing the personal healthcare information. So the promise of precision medicine requires complete access to all available data about an individual. So what is precision medicine mainly deals with is making the data available to everyone. Okay, so over past few years, digitization of health records has happening in form of electronic health records and has covered a vast majority of hospitals and physicians. Okay, so here actually we all our health, whenever we go to an hospital we can find all our records are digitized. They don't have, they also they maintain some files, but it is all in our system. The systems also the centrally in the central server we have they are maintained, okay, in the all our data, okay, and it is not decentralized. And the paradigm shift in the next generation of healthcare will be decentralizing this information about the patient health records over every hospitals. Okay, so it is happened in abroad countries, and in India it may take some time or some more proof of proof of concept has to be developed to make people believe about or make the what is that hospital management to come forward to implement those scenarios. So the machine learning and the blockchain technology are two data driven technology that are rapidly growing interest in and integrating them for clinical management data and analysis in healthcare. And access to the complete history of patient data is restricted due to high patient mobility across multiple hospitals and clinic. See, nowadays, normally in current scenario, we will not able to take our records. Even though we are the patient of one hospital, we will not be given our records. Our health records will not be given to us, okay, as until it will maintain only in the hospital. நமக்கு ஃபைல் கொடுத்து அனுப்புவாங்க, பட் அந்த ஃபைலில் வந்து வெறும் பே பண்ண பில் காப்பீஸ் தான் இருக்கும், ரெசிப்ட்ஸ் தான் இருக்கும். Okay, but we will not find any of our health record information in our files. It will not be disclosed by the hospital, because once they disclose that, one patient can take that records to another doctor, get the medication from them, and get and move on from their hospital. So now that's all the business motives are around the medical field. But in future, okay, this will change. Okay, they make there may be that for that only for restriction on that type of policies only. This decentralizing the medical health records, all these policies are coming into existence now. However, these machine learning techniques can empower the personalized medicine and also enhance quality of diagnosis. And similarly, blockchain technology has suggested as a promising tool to store the healthcare records for sharing, for exchanging, and for analyzing purpose among the different CAD providers. Electronic health records is nothing but the computerized representation of the medical history, progress note, issues, and medicines. Okay, as with any online digital format, the concern of breach exists. Is also susceptible. Here also we have some issues when challenges when we face we will face when it is getting implemented. So this is overall the picture or representation of what I'm speaking. So it is like like all the diagnosis or the data, health data, medical record, all are available, and we can apply machine learning techniques or and provide a prediction or SVM based algorithm for prediction. Okay, and which can be used by the hospitals or healthcare services or by community health centers. Okay, any type of sub services you can provide. And where is the role of blockchain is on the top. So it is like for preserving or securing, for privacy in preserving, or for all these things, this blockchain concept is coming into role. Okay, have you understood? Have you understood what is about the technology we are going to study? Yes, yes. Can you able to follow, all of you? Please give me a response, any one of you. Are you, or everything is, you are able to follow what technology we are going to study now? My voice is audible, right? Hello?
Yes, ma'am. Yes, ma'am.
Yes. Okay. So I got a doubt on whether my connection is there or not. Okay. So we'll proceed. First, we are going to continue with electronic health records. So electronic health record is a digital format of the patient health information, okay, which consists of patient contact information or the vital signs, medical history, current and past medication that is outsourced to cloud. Okay, so EHR has got a very important vital role in health IT, and it contains all, as I said, it contains the medical history, diagnosis, treatments, and all the medication, laboratory test results, and it allows access to evidence-based tools that providers can use to make decision about the patient. So you can apply evidence-based tools over an electronic health record to just to get the make a decision. And next is electronic health record are built to share information with with the caretakers, okay, with the healthcare providers. Healthcare providers, you mean the doctors or the hospitals or the laboratory people, or the scan people who do scan or blood tests, something like that. All are healthcare providers. Okay, and the organization, so that so they contain information from all clinicians involved in patients healthcare. So they involve the entities who are using the electronic health records can be laboratories, medical imaging facilities, pharmacies, and any emergency facilities. And for emergency facility also, they wanted to know about the patient health record, so they can access to EHRs, emergency ambulance, and other facilities. So this is just a representation of what is electronic health record. It is a digital format. It contains patient health information. It provides sharing, or it provides a sharing among the authorized specialists. They provide security. That is, they provide real-time patient-centered records securely, and they provide easy access. Okay, with the help of cloud. So the proposed solution here will be proposing a blockchain-based security architecture for maintaining electronic records. So our concern is like these electronic health records, which shows the patient information, must be secured. Okay. So for that, what is the proposal idea we have is the blockchain. So I'll just explain you on the basics of blockchain and how it has been implemented, what are the framework of blockchain and all those things. It provides a privacy using non-interactive, lightweight, zero knowledge proof authentication method. And zero knowledge proof is one method which does privacy preservation. So the objective is to design a secure, decentralized medical blockchain to address privacy and security concerns associated with exchange of patient healthcare across the entities. Yeah. Yes, we come again. We'll start with the basics of blockchain. So what is a blockchain? So it is a distributed database or a ledger that is shared among the nodes of the computer. Okay, so it is just a ledger that is shared among different nodes of a computer. It is as a database, like a database. The blockchain will also store information electronically in digital format. It guarantees the fidelity and security of the record and guarantees trust without the need for trusted third party. So there's no need for trusted third party, but it guarantees the security. How it does is it maintains a hash. Okay, hash value is added in each hash value of each of the blockchain. So each of the block will generate a hash value based on the hash value generated in the previous block. So if one block is altered, okay, all the other blocks will also get altered, and you will know about the intrusion that's happened to your data when it is added in the blockchain. So that is what we do here, right? So best known cryptocurrency which is used mainly here is the Bitcoin. So for maintaining the security and decentralization of records. Yes. So next is what does the blockchain? How it is different from others? So blockchain collects information together in groups known as blocks, and it holds the set and it holds the information inside it. Okay, the key difference is how the data is structured. So this is the just working of blockchain. So it is like first you have to initiate the transaction, and next we have to make a verification. So once verification is over, you can add the blocks, and for each blocks and a new block is based on the and you can continue adding new blocks again and again. So each of the block will hold some information. Okay, so this is what the working of a blockchain. So first you are going to make a request, then verification, then you are going to add the block. The block is going to hold the information. Okay, yes. So what is the steps again I had listed? First your authorized participant inputs a transaction, and next which must be authenticated by the technology. Then he creates a block. Okay, block is sent to every other node in the network. So and they will authorize it. Authorized node verify the transaction. They add the block to the existing blockchain, and update is distributed across the network, which finalize the transaction. Okay. Yes. So this is how the working of blockchain. So what is how its security is maintained here? So here it is like as I said earlier, user will initiate the transaction, data request is begin, and when the transaction is initiated, a new block will be added. The block has to be added in the will be added in the blockchain. And in order for a block to be added in the blockchain, it has to be verified by all the other miners or all the users of the blockchain, and that is going to, that is done as a second level of verification, and it will validate the block after all the users are validated. It will add it in the blockchain. After the new block will be after that a new block will be added, and the process will continue until all the information you wanted is added into the blockchain. So this is how you add the information into the blockchain. Okay, nice. And next is only the authorized participant will initiate the block creation, and also if every miner or user verifies the block. Okay, yeah. So it is like how why we say that blockchain is secure. So the new blocks are always stored linearly and chronologically. That is, they are always added at the end of the block. You can't add the block in between. After the block has been added to the end of the blockchain, it's extremely difficult to go back, and altering its content is also very difficult unless a majority of network has reached a consensus to do so. And each block, it contains its own hash value. So along with the hash of the block before it, okay, and as well as the timestamp, it will calculate its hash value. So hash codes are nothing but the mathematical function that turns the digital information into the string. So if the information is edited, this hash code will also change, and that will make all the blocks to alter, and so that we can know about the changes that is made to the information in the blockchain. So that's how the blockchain itself is secure. You can say blockchain port away, it is already secured. How it is secured? It is because of the hash code value. Okay. And next important part of any blockchain is the consensus algorithm. So blockchain is secure only because of the presence of consensus protocol, which is a core part of any blockchain network. A consensus algorithm is a procedure through which all the peers of the blockchain network reach a common agreement about the present state of the ledger. Okay, in this way, the consensus algorithm will achieve reliability or in the blockchain network and also establish trust between the unknown peers in the distributed computing. Okay, so that's how we are making the blockchain more secure, right? And next, essentially, the consensus protocol makes sure that every block that is added to the blockchain is one and only version of the truth that is agreed upon all the nodes in the blockchain. So this is what the strength of the consensus algorithm. Okay. Yes. So once you say that once you find the consensus, any disturbance about this is agreement or the trustworthy is not maintained, you can say the consensus is failed. Each node proposed different nodes, so the majority is not achieved, so consensus failed. So all participants of the blockchain must agree upon adding the block. Only then the information will be added to the blockchain. So every information present in the block will be known to all other participants, so each other participant. Okay. Yes. So coming to the next point is about the type of the blockchain. So we have different types of blockchain, which namely public, private, then permissionless and permissioned. So public means everyone can read the blockchain and submit the transaction. Everyone can access it. Private means only entities included in the predefined list read a list which is in the list are ready are permitted to do the transaction. Permissionless means here everyone in the allowed list everyone is allowed to create a block. Permission similarly is opposite to that. Only in the list, people who are in the list only are allowed to do create a block. Yes. So coming to the next topic, that is on blockchain framework. So how will you implement this blockchain? So this blockchain is can be implemented in two ways. One is by using the Ethereum and also in the Hyperledger. Okay, so Hyperledger is like these are the two framework in which the blockchains can be implemented. So first we will study about Ethereum. So Ethereum blockchain, it is a truly centralized, decentralized blockchain that is comparable to Bitcoin blockchain tech network, and decentralized. It's decentralized, open source, permissionless, and with smart contract functionality. And the programming we used for writing Ethereum smart contract is called Solidity. Okay, so here we have Ether is the native cryptocurrency of this platform, and among the cryptocurrencies, Ether is the second only of two Bitcoin in the market capitalization. Okay, so I'm just giving an introduction about Ethereum blockchain. So it is how the programming that you use to write the smart contract is the Solidity. Okay, so we'll just know about what is Ether. As I said, Ether is a cryptocurrency generated by the Ethereum protocol as a reward to miners in proof of work system for adding blocks to the blockchain. So only with the proper valid Ether, the person or the person will be able to add the blocks. Okay, ETH, it's always called ETH. Ethers is only currency adopted to pay for transaction fees, which also go to miners. Okay, and for each of the successful transaction, you will also get awarded with the more ethers. So block addition reward together with the transaction fee provide the incentives to the miners to keep the blockchain growing. So once your transaction is successful, you will be rewarded with more ethers. Okay, so each Ethereum account has an Ether balance and may send ETH to any other account. So if you have more balance, you can send the balance to your friend also. Okay, so this is how you can develop a blockchain over a public network. For this involves some money. So what you do is, without involving money, there are some frameworks, so you can create a dummy ethers which will be useful for trying and executing or on practicing on writing the smart contract and deploying it to the known circle. Okay, so that is also available in Ethereum. Next, open source framework for blockchain implementation is Hyperledger, and it's an open source community. It's an open source community focused on developing a suite of stable framework tools, libraries for permissioned enterprise grade and blockchain deployments. So it is based on Linux Foundation, hosted by Linux Foundation, and it does not support Bitcoin, but here also, but it does some rewards, okay, for successful transaction. So works by providing the necessary infrastructure and standards for developing various blockchain for industrial use. Okay, so Hyperledger is a hub, okay, where various individual blockchain projects and tools that adhere to its defined design philosophy operate under its umbrella. Okay, so it's a hub, or it's an open source foundation which is developed by Linux Foundation, which is used for widely for developing blockchain. Yes, in that there are so many variations of Hyperledger. Hyperledger Fabric is there, Hyperledger Sawtooth. We'll be studying on Hyperledger Sawtooth. So Hyperledger Sawtooth is an open source enterprise blockchain as a service platform that can run customized smart contracts without needing to know the underlying design of core system. So it is an open source blockchain as a service platform, and an umbrella blockchain development group sponsored by organizations such as Linux Project, IBM, Intel, and SAP. So here, how it is they support? It supports a consensus algorithm, which includes BPFT, which is practical Byzantine fault tolerance and proof of elapsed time. So this one you can know about the proof of concepts later. When you wanted to know, you can read this. That is not much here. And difference between these two, Ethereum and Hyperledger, I will just elaborate. It is like in the Ethereum tool, we have it is permissionless public blockchain. Here permissionless and this permissioned, and here the consensus mechanism is proof of work, and here it is pluggable mechanism, Hyperledger Sawtooth. And here the benchmark tools here for evaluating, okay, both of these framework. We have EVM Remix is the tool that is used for evaluation, and here in Hyperledger Sawtooth we have Caliper, and ledger type will be like no permission, and here it is permission. Governance, it is by Ethereum developer, this is by Linux Foundation, and programming is by Solidity, and here we call it as chain code. Okay, and the cryptocurrency we have ethers, and we don't have anything here. So that's all about the Ethereum framework. Now we'll move on to zero knowledge proof on how so security is done over of the electronic health records is done by blockchain. I will explain on how it is done. Before that, we will understand what is zero knowledge proof. So zero knowledge proof is that each of the provers. So it is like for only it is to make the only the valid user to access to the secret data. With how not to access to that secret data, they have to verify their proof. Okay, for that they need not give the proof, but they will just give an indication that they have a proof, which the verifier will authenticate to access and make them to access to the secure data. So that is what zero knowledge proof is. So it is like you have this red so see, I just this animation that you are able to see from starting. So yeah, it is like a ball, both have the ball. Check this one, and he's asking okay, and he will just second round friend, it is again identical. He says it's no, it's not identical. Okay, so the verifier will verify with the proof that is not actually given by the user, but he will just make an authentication on the proof that he have, and with that he will verify. So that's what I have listed here. So zero knowledge proof is a proving algorithm that allows a piece of information to be validated without actually exposing the information. So the essence of zero knowledge proof is that one proves that they know something by simply relieving it. So challenge here is we will be proving that they know the information without actually exposing the information blockchain in the list of records that are managed by various distributed parties, where each party can have a copy of the list. So here the blockchains make all the transaction visible to all parties, and it also it will mean like they don't provide which means they do not provide privacy. So for that only, this zero knowledge proof will ensure that privacy is ensured. So ZK SNAF, it provides us with a way to prove that the transactions are carried out without actual relieving and information actually relieving the information about it. So with the famous zero knowledge proof algorithm we will be demonstrating here is ZK SNAF. So what is ZK SNARK is? SNARK is succinct non-interactive arguments of knowledge. So that is ZK SNARF. Okay, it provides a way to prove or verify the correctness of computations without having to execute them and without having to relieve any secret information they may have gone into the computation. Okay, so that is about ZK SNARF. So verifier just know the computation was done correctly. He will not relieve any of the information that is actually uh, relieved. I not relieve actual information. Okay, so that's about the structure of blockchain with zero knowledge proof for electronic health record. Okay, so just observe this. It is like what we explained over blockchain, over electronic health record. It's how it is applied or converged together, how the latest technology of blockchain or privacy preserving is applied over electronic health record. So here we have the entities who are using these electronic health records include doctor, hospital, user, medical researchers, and all the data about the patient. Okay, this is the patient data. It is all stored in the cloud. Okay, and this is about proposed. This is the existing one. This is the proposed one. So here you are now going to have the same patient, doctor, hospital, researcher, user, pharmacy company, or drug developing concern. Everybody will have access to the data, which is in the blockchain. So in the cloud, it's called cloud blockchain. Okay, so the user, each of them will have a user will have a user registration, and they'll have a code for accessing this blockchain, and all this access to this electronic health record is happened securely, and privacy of data is also maintained with the help of blockchain and ZK SNARF. Okay, yes. So the proposed architecture is like, so blockchain based decentralized secure healthcare system with the help of lightweight and authentication encryption technique above methodology above so the this will help securely exchanging electronic health data between patients, doctors, hospitals, and other medical agencies for research purpose. So they, what is that they proposed architecture include is like they have a KDC, that is key generation center, and EHR encryption and blockchain creation, smart contract, and EHR description. So by using this proposed architecture, it ensures privacy and security issues of the outsourcing EHR on cloud using decentralized and immutable blockchain ledger. Okay, so the proposed architecture yes, proposed architecture uses a lightweight authentication encryption algorithm to upload the encrypted data over a decentralized cloud-based blockchain. It achieves better execution time and increased performance of EHR. And the architecture employs separate key distribution center for generating and exchanging the public keys along with secret key through an unsecured channel for ensuring and decrypting the EHR record. And this leads the proposed architecture to achieve EHR data immutable, decentralized, traceable, anonymity using cloud-based medical blockchain technology. And how to write the smart contract, it's like the primary, so each of the blockchain is equipped with a smart contract in order to ensure that all the information are secure. So in that case, we can write the primary function is to add the blocks for patient, pharmacy, doctor, all those information in the blockchain. So functions like add doctor, add patient, add pharmacy will all can be all added. Like you write a normal business logic for or a procedure, or for coding for any application, you can write the functions definitions for them in the smart contract of a blockchain. So if a patient wants to consult a particular doctor, he or she will send their details to the doctor using the function patient details to doctor. Similarly, the patient analyzes the doctor and generates the electronic record based on the patient health condition, and that will be available in the blockchain. And now the doctor uploads the electronic health record of the patient to the blockchain using set record. So for updating that, uploading his prescription of medication on the diagnosis of the information about the patient, he can use the doctor will use the blockchain function set record and generate the prescription and upload it to the blockchain with the help of set prescription. Okay, so once the set prescription is given, again, to pay the fees, the patient use transaction functions like accept accept doctor as a parameter. Now the patient can now see the prescription details and send them to the pharmacy and to get the medicine. So no need to take the pharmacy for the bill or the prescriptions to the pharmacy. When you go and say about your ID, the pharmacy will access to the electronic health record of the patient, and they will give you the medications. So patient receives the medications and medicines and pays to the pharmacy. And function get patient can be used by the doctor to get the details of the particular patient. Similarly, the patient can view the doctor's details by using get doctor function. Also, the patient can view about their details by using get records function. So in this way, the data is made decentralized, and it's not just only one hospital management is going to access this to this electronic health record of the patient. It will be any user, any of the hospital system over the globe can access, or toward the scope of where you deploy this can be used for setting up this blockchain. Yes, and we have analyzed this with various results, and it is found that the Ethereum, we have analyzed it with Ethereum and Hyperledger on implementing over the electronic health records. So we find the threshold throughput of on average latency of this blockchain is much. Just one second. Hello. Yes, of this electronic health record is just this is like average latency and throughput for Ethereum blockchain is much more improved. Okay, when compared to Hyperledger, you can find the observation is sending 650 transaction in Ethereum. The transaction per second is 14.3, whereas in Hyperledger Sawtooth it is 32.8. So you can say the Hyperledger Sawtooth is faster than the Ethereum. Okay. Yes. Just hold 1 second. Okay. So sorry for this interruption. I wanted to attend an important call. So we'll move to this. Yes. So this is how the performance of the Hyperledger and Ethereum are presented, and we find that Hyperledger Sawtooth is faster than the Ethereum. Okay. So to conclude, I can say the proposed framework, okay, provides or includes a decentralized healthcare system to protect data integrity and privacy in a scenario of multiple blockchain based connected networks, and incorporating the zero knowledge proof into the healthcare system to verify doctor's license, valid prescription, and patient insurance details without revealing any sensitive information. And with the future advancement of technology, more features like third party validating, security, privacy enhancing algorithm can be applied to improve the whole system. Okay, so that's what I wanted to convey in this session, and this over. I hope everybody of you have got a good idea on how electronic health records or security or data privacy is maintained over the blockchain, over by using a blockchain technology. Any questions? I am happy to take up any questions from the users or from the audience. Please let me know any questions you have so that I can address them for next 10 minutes. Yes. With respect to the morning session also, you can ask me.
Ma'am, in the
Yes.
blockchain, can you
Yes, sir.
explain fundamental way? Suppose if a bank has 1,000 accounts, if you
Yes,
want to
sir.
open a new account, if you want
Okay.
to open a new account, whether this has been informed to all the existing 1,000 records?
No, sir. Actually, I'll just explain. For example, for adding a new account and all will not happen. For creating the information of the user in the blockchain, we will be adding all the information about the users in the blockchain with the authorities involved in developing the blockchain. Okay, with the bank authorities, with the customers, we will be adding the blocks, and it will not be information about the customer who is going to create an account will not be relieved to all the people in the blockchain, all the entities in the blockchain. But adding a new customer, it will be we will pass to we will like it will be like add customer, add a new account or open account will be a smart contract in the blockchain, which will give an intimation to all other entities in the blockchain who are using it, not to all other customers.
So the existing system also like that, ma'am. It support for
Yes.
that.
Yes.
What is the difference? The existing system, if you, when the new customer adds, he has to
Mhm.
popularize his account number or something like to others to transact
Yes.
money or something like.
Yes. Yes, sir.
So how the blockchain is differ from this?
Yes. So with the see banking sector now it is decentralized. Actually, with respect to we can't say it is fully decentralized. We can say like with respect to only one bank, the account details or you can send and transfer, or we give with the other account details you can transfer. Okay, it is happening in a secured way. Blockchain here, it is like for accessing to the common data. Okay, for example, healthcare records of a patient may not be available outside the hospital. They have
Hospital,
to go and take
hospital.
the scan or the all the electronic health record, all the tests again in a new hospital, which involves a lot of money wasting in there. And also people will frustrate and know, since as a user, as a patient, myself, I will not be able to access my record. So in that case, I want, when the things has to be decentralized, this type of blockchain must be there to have security. But when we speak about the financial sectors, we have actually it has been happening. It is happening. That is the security protocols and other things have already come into play, and that's the reason people are now without any hesitation they are moving towards digitization on making payments online or using the online transaction or gpay. All transaction, no cashless transactions has been becoming popular because of the confidentiality and the security involved in the system. Yes,
Can you say
definitely.
GPA is having blockchain?
No, sir. All most of the transactions or financial transaction, definitely they will have some security measures. We can't say it is directly blockchain. It is going to be some type of security measures. Even whenever it is to be decentralized, adding on with the blockchain is very important, sir. We find our students, okay, we find gram niti was one of the project which was selected in Finnovatica or in a hackathon like event, which where they applied the usage of blockchain over the financial sectors for secure transactions. I don't know about what is existing now, but they are being into play on providing secure transaction over a decentralized network.
Okay. Can you give
Yes.
one small example of blockchain, ma'am, so that we can understand? Because it's
Mm.
something is above our understanding level. We are
Sir, it is like
thinking that
I can
we
just
know the linked
yes.
list. Yeah, block is there and pointer is there, and it will point it to the next block like that. We have studied in
Yes. So I
programming
will say a
languages.
small another case study on voting system. Okay, on a
Okay.
voting system. So we normally when we go for actually it is a very important case study. Wherever you study the blockchain, the first case study that they will explain is on the voting system. So it is like it is happening over the over a particular state, right? Universally, right? The voting,
Yes, ma'am.
right, sir? So
Yes.
it is like the polling. When the polling started, it has to be closed on the same day, and the results will be it has to be very much highly securely done, and also only based on identity of the user, each one has to poll, right?
Yes.
So
Yes.
there is that is a very very good example of a blockchain. So for each of the way there will be smart contracts for adding entities into the poll, and the user as a voter, okay, who user as a voter, they will be just providing the vote, and once they added the information that cannot be altered by anybody. So it is just the same system of voting where we go to a poll and we add our identity, and we put the vote. The same way it is in the blockchain means we for example in US and all, we don't they do only online polling. Okay. So but in India this may come in later or later years, online polling, where this blockchain may be very good idea. So information about the user who have voted to which party will not be released anywhere. Information what they added also will not be altered by anybody, and finally end of polling the results will be announced very good. So it is nothing but the information what is
Okay.
already there will be added, and they and what information we add is always secure. It's always secure. In electronic health records also, all the information about the patient will be added into the blockchain, and they can who are the entities of the of that electronic health record will be given access to that, and they will get the access. And once anybody wanted to try to alter it, since because of the hash code value, with the one, since one block generate the hash code based on the previous block's hash value, it will alter. One any intruder wanted to try to change any information, it will alter the entire information of the block, and they will
No,
know about
that means when the person is voted, it
Mm.
will be added in the blockchain link.
Yes, sir. Yes. So he will
Hello,
just
am I
he
audible?
yes, sir. He or she will be calling to vote.
Added in the link.
Yeah, he will just make a vote
Okay.
on to the corresponding entity where to whom they wanted to vote, and the counter value of that corresponding party will be incremented. That's all. And identity only
Okay.
once it can be used. So no time, nowhere again the same identity or the same person can be used again. So it is some it's a system
Okay,
where
ma'am.
the data is very secure. So it is just understanding, for clear understanding you can try with Ethereum or Hyperledger platforms, sir. It is very clear on how it has to be done. So it is with the interest like you only, I also got interested to learn about. Everybody were taking on asking or speaking about blockchain. With my own interest only, I learned about this. Not my research area actually. My research area is data science, machine learning, deep learning. with more interest on blockchain, since it deals with a huge amount of data. I added my knowledge on knowing this. So we started with implementation of the things in Ethereum, and then we've moved to Hyperledger Sawtooth and compared its performance. So a simple case study, you can either with voting or with electronic health records, you can try implementing a small case study. It will give you a good understanding of what is that, what I have been saying this much time, sir.
Okay, ma'am. Thank you. Thank
Yes.
you very much,
Any
ma'am.
doubts, you can please call me, sir. We have, again, since we have implemented, we are now knowing about it, and it is like in for real time implementation. We need to involve. It involves some money, or we need to spend that ethers. We have to buy some ethers, which our students have got it from Smart India hackathons and other hackathons. They get some funds, and then they will be using that for real time implementation of their blockchains.
Okay, ma'am. Thank you,
Yes,
ma'am.
sir.
Thank you very much.
Yes. Yes, sir. Thank you. So I hope I have given some good insight on what is on this blockchain is all about. It is, again, as I said to sir, it is out of my own interest only. I have also studied and explored about all this information. It is very good to know about that, and I have my part on. I'm researching on adding privacy and security to the data involved over the blockchain. So there are more scope for research also. So I encourage everybody to apply on and apply it on a small case studies like voting or in healthcare records. Okay, and also there are so many GitHub codes also available, so you will gain more idea on these things. Ethereum and Hyperledger frameworks are very good to work, and learning Solidity is also easy. It's similar to C. Writing functions like in C or in Java, we write functions in smart contract. Smart contract is nothing but the functions that we write over for building a business logic. That's all, sir. So it is going to be good knowledge you will gain once you start with implementing these things over this Ethereum and Hyperledger framework. And any doubts you have, you can call us at any time. We will be happy to help you.
Okay, ma'am.
Yes.
Thank you. Thank you. Thank you.
Yes, sir. Any more questions? Okay then. So thank you everyone. Thank you all for your patient listening. I hope that I have made some. I've shared some of my knowledge over these two sessions in today's 2 day session, and I like to thank the management. Mainly, I would like to thank Dr. Yogapriya, Dean and Research R&D of Kongunadu Engineering College and Technology, and the management principal Dr. Ashokan sir and Dr. PSKR Priyasamy sir, Chairman sir, for giving me this opportunity. And I like to thank all the participants, our audience, and the professors and all others people who are here for the patient listening. Yeah, thank you. We'll meet on some other occasion, on some other venue. Thank you then. Over to Master of Ceremony. Yes.
Thank you, ma'am. Thanks for your wonderful seminar. Thank you, ma'am.
Yeah, thank you,
Thank you,
Kavya.
ma'am.
Yes, thank you, ma'am.
Success is only meaningful and enjoyable if it feels
Thank you,
like
ma'am.
your own. I like to call upon Dr. R. Satya ma'am, Assistant Professor of IT Department, to give away the vote of thanks.
Ma'am, very good evening, ma'am.
Good evening, Satya ma'am. Yes, good
Okay.
evening.
Very good evening, one and all listen here. First of all, I would like my hearty thank to Department of Biotechnology, DPT, for giving to organize one-day national level seminar and also for giving the financial assistance. I would like to thank Honorable Chairman Sir and Principal Sir for giving this opportunity. I would like to hearty thanks our resource person, Dr. D. Kartika Renuka ma'am and Dr. V. Chandran sir, who spared time from their busy schedule to grave the occasions. Today we had an opportunity to hear your nice and valuable information, and this will surely to be going to encourage us in our future. Then I would like to thank uh, Dr. J. Yogapriya ma'am, Dean and R&D, and Mr. N. Prem Kumar sir, HOD, Department of IT, for entire support and guiding how to organize the event in successful manner. I would like to thank all the participants from various colleges who spent the valuable time with us. Finally, I would like to thank our faculty members and beloved students for cooperating this event. Thank you. Thank you so much, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you. Bye, ma'am.
Ma'am, bye,
I
ma'am.
can
Thank you.
leave,
Thank
no?
you.
I can leave the link, right?
Yeah. Okay.
Yes, ma'am. Thank you, ma'am.
Okay. Thank
Bye.
you. Thank you, sir.
Thank you, ma'am.
Thank you all. Yes.
Participants, fill the feedback form and leave the session.
Ma'am, please share the feedback link, ma'am.